So today we're going to talk about rational exponents. Rational exponents are really just radical expressions in disguise. Use the following rule to convert between the two. If I say a to the m over n, that's the same as whatever is in the numerator is the power I'm raising it to, and in the denominator is the root. So let's look at an example. If I have this, what I would do is I would say the square root of inside 8. But now instead of actually square root, in this case it's going to be the 7th root because that's in the denominator. And that's going to be squared. We could also say the 7th root of x squared, even though in reality that's pretty much the exact same thing. How you would do it is probably a little different though. All right, so let's try this one. So in this case we're going to say c. Now it's being raised to the 3rd power, so that's a 3 in the numerator, and it's a 4th root, so to the 3/4 power. Here's our last one, 4, and inside you'll notice it's squared to the square root, which means actually I don't even need that 2. By the way, the square root of 4 is 2. Okay, so now we're going to talk about some properties of rational exponents. Here's each time a property and example. Our first property, if I say x to the m times x to the n, it's going to be where we add it. So like x squared times x to the 5th is x to the 2 plus 5, 7. So x to the 7th. On the other hand, if I divide, I subtract. So x to the 6th divided by x squared, we're only going to have x to the 4th. Now, if I say x to the m to the nth, I would multiply m times n because, for instance, if I say y cubed to the 4th power, I'm saying that there are 4 sets of 3 y's, or 12, as opposed to y cubed times y to the 4th, where it's a set of 3 and a set of 4 being 7. Here's our next one. If I say x times y to the m power, then each of those could be done separately. So a times b cubed is the same as a cubed b cubed, or for instance, we could also go the other way, where if I said like the cube root of 5 times the cube root of 25, we could also say the cube root of 5 times 25, which would be the cube root of 125, or just plain 5. Here's another example. In this case, if I'm dividing, same type of thing. We tend to see this a lot with like the square root of 25 over 9 being the same as the square root of 25 over the square root of 9, so, 5/3. In this case, if I'm raising something to a negative exponent, what that means is that is going to go, if it's in the numerator, to the denominator, or if it's in the denominator, it'll go back up to the numerator. So 2a to the negative 3 becomes 2 over a cubed. The reason why the 2 stays on top is it's not being moved by the negative 3. Now 4 over y to the negative 5th power is 4y to the 5th. So let's try this out. This is the same thing as saying the cube root of 64, and at this point we've talked about it quite a few times. But the cube root of 64 is in fact just 4. All right, here's our next one. There are actually 2 ways we can do this, but what I'm going to do is I'm going to take the x to the m times x to the n approach from earlier, where we add them together. So 7 to the 1/2 plus 1/2, which is the same as saying 7 to the 1st power, or just plain 7. Now, there is another way we could do it, but we're actually going to use that method on this next question, where we have 5 to the 1/3 and 25 to the 1/3. That means we could say 5 times 25 to the 1/3. Now, if this looks familiar, it's because I literally just did this one with you. It becomes the cube root of 125, or 5 as your answer. Okay, let's try this one. 32 to the 3/5 power. Now, some people might want to first cube this, but I'm going to first find the 5th root of 32 and then cube it. So 2 times 16 2 times 8, 2 times 4, 2 times 2. Hey, there are 5 2's, which means it becomes 2 cubed, or 8. All right, now for this one, what we would end up having to do is we'd have to, basically first I'm noticing the negative. So I'm going to go 1 over 3x to the 2/3 now cubed. So what that means is 1 over 3 cubed and x to the 2 times 3 over 3. So 3 cubed is 27, and 3 over 3, those cancel out, meaning it's just x squared. Let's try another one. So in this case, I'm going to go put everything on the bottom. This becomes x to the, I'm just going to start multiplying as well, 2 times 12 over 3. And then y to the negative 1 times 12 over 3. So that ends up becoming 1 over, in this case, let's see, x to the 8th, y to the negative 4, at which point, notice that y, in this case, is at a negative 4. That means this will become y to the 4th over x to the 8th. Okay, let's try this one. And in this case, what we're going to do is we're going to say x to the negative 1/3. So 8 to the negative 1/3, I mean. So that really just means 1 over the cube root of 8. And then I'm just going to say x to the 15 over 3. So that becomes 1 over 2 x to the 5th. And that's actually it. We're done. So if you would please subscribe right over here. Also, feel free to watch some videos. I have some videos. They're probably, I'm guessing, taking over this question right over here. And just like, comment, all that jazz. Have a great day. See you later.